Today we're going to look at the last lesson in our Chapter 9 packet, Lesson 9.3, Residual Plots. So we talked about residual in 9.2. That was the difference between the actual and the predicted. So we're going to start out with the data of all the iPhone sales during their opening weekends from the original through the 6S. And we're going to use the year as our X and the units sold as our Y. So the first problem wants you to create a scatter plot for it. So if you don't remember the steps, you can look back in 9.1. Go ahead and create a scatter plot from this data and come back for the answer. Okay, hopefully you got a chance to try our scatter plot. It should look something about like this. We have our dots, and they're going in a pretty good direction, pretty tight formation. So it wants us to describe it using ducks. So this will be on number 2 for you, but I'm going to write it on this screen so we can see everything together. Our direction would definitely be positive. We can see that as X is getting bigger, our Y is getting bigger. Unusual or outliers, I wouldn't say that we really see anything there. Our correlation, you might be tempted to say linear, but if we look closely at this, we can see an uptick. We can see it go like this, and once we see that line, you can see that that would be exponential. So we would say nonlinear. And then our strength, I definitely would say strong, and we'll see that whenever we do our correlation coefficient. So what number 3 is, it would like you to find the correlation coefficient. So you've already got your data entered in from creating your scatter plot. So just go stat calc 4 and you'll find that correlation coefficient. So we should get an R value of 0.956, which would definitely fall into our strong, our positive strong correlation. So along with residual plots, we also get an R squared. When you run that stat calc 4, you'll see an R squared. That is the percent variability that is already accounted for by the least square regression line. So there is that difference that your R is getting from your residual between your predicted and the actual. And that R squared is how much is already accounted for when that least square regression line is created. So the higher the percentage, the better fit of the regression line. This can be found in the same place as the correlation coefficient. You'll see when you look up that R, you'll see R squared right above it or below it. So we use these in our residual plots. So a residual plot is a scatter plot showing the difference between the actual and the predicted values. So this would be a good residual plot because it is random. You want a random residual plot. Whereas the one to the right, this one would be bad because it has a pattern. You want residual plots to be random because when you see that pattern, that means that you don't have a very good regression line. So we have some calculator steps for creating a residual plot. You make sure that your data is in X and Y, and you make sure that your X and Y data is in L1 and L2. In Y equals, you will turn off plot 1 and you'll turn on plot 2. And then you'll hit second Y equals 2. And you'll see Y list. So you'll go down there and you hit second stat 7 and then zoom 9. So it's a lot of steps, but if you just make sure that you do each one, it will pull up your residual plot. So you should still have your X and Y data in your calculator from creating our scatter plot earlier and finding our correlation coefficient. So go ahead and follow the steps from here. Y equals, turn on plot 2, follow each of those, and create your residual plot. Once you've done that, we are going to talk a little bit about choosing the best regression model. So in order to choose the best regression model, we look for the residual plot with a random scatter of points. We just talked about above that that was a good residual plot, and we want the highest R-squared value. So with our same data that's in our calculator, our iPhone data, we're gonna go back to our StatCalc 4, grab our least square regression line and our R-squared value. So our R-squared should be 0.914. And then following those steps from the previous page, look at your regression plot, not regression, your residual plot, your residual plot. And let's go ahead and sketch that out. So you can pause the video and come back once you've sketched it. Okay, it should look something like this. And we can see that it kind of has a pattern. It kind of has almost a quadratic to it. So that pattern is bad. So let's try running a quadratic regression. So instead of doing StatCalc 4, we're going to do StatCalc 5. Okay, and StatCalc 5 is going to give us an R-squared of 0.984. And we need to rerun our steps for our residual plot. So go ahead and rerun those steps for the residual plot, and then sketch out your residual plot and come back for that answer. Okay, so your residual plot should look something like this. This is a lot more random than our previous one. So this is good, random. So which is the best regression model, the linear or the quadratic? Remember, to be a good regression model, we want it to have the highest R-squared value, and we want it to have a random residual plot. The quadratic has the higher of the two R-squared values, and it has a random residual plot. So our best regression model would be quadratic here.